Factors affecting gas pressure. Section 12.2a. After reading Section 12.2, you should know how the amount of gas and the volume of the container affect gas pressure, how a change in temperature would affect the pressure of a gas, the amount of gas. When you pump air into a container, such as a tire, you will increase the amount of gas inside that tire or that container, which increases the number of collisions between gas particles, which then increases the pressure. Relationship is direct. If you double the amount of gas, the pressure will then double. Picture examples. In this picture, we're adding air particles to a container, and here's the end result. So this is without the air, and this is with the new air particles added in. As you can see, the temperature is still the same, but the pressure has increased. So here we go. Fewer gas particles, low pressure. More gas particles, higher pressure. More gas particles, pressure is higher. Fewer gas particles, low pressure. In a sealed container, gas moves from an area of high pressure to an area of low pressure. So inside this can is high pressure. Outside in the atmosphere, low pressure. So when you press the nozzle, the inside air pressure will push down, and it will force the product. If it's hairspray, it will force it up the tube and out the nozzle. Volume. If the volume of a container is reduced, the pressure will increase. Here we have a standard size container. We shrink that container, the pressure then increases. We also see temperature increasing slightly also. If the volume of the container is increased, the pressure will decrease. So here we have a smaller size container, and we expand it. So the pressure here goes from 1.22 to 0.76. So the smaller the container, the more collisions, the more pressure. The larger the container, the more space, the lower the pressure. The relationship is inverse. If the volume is doubled, the pressure will decrease by half. Temperature. If the temperature is increased, the particles will move faster, which causes more collisions between the particles, which then increases the pressure. Increasing the temperature causes the pressure to increase. So here's a standard container, no heat being added. The same standard container adding heat. So we take a look at the pressure, 0.41 atmospheres, and it gets increased to 1.22 atmospheres by adding heat. Decreasing temperature will cause the pressure to decrease. So here, standard container. Here we're going to cool it down. So the pressure goes from 0.41 to 0.25 by cooling it down. The relationship is direct. As the temperature is doubled, the pressure is then doubled. As the temperature is decreased by half, the pressure will decrease by half. After reading section 12.2, you should note the amount of gas and the volume of the container affect the gas pressure and how a change in temperature would affect the pressure of a gas. Thank you.